Welcome to the webinar, Why Innovation Fails, a Risk Management Problem. My name is Josh Haslam. I'm the Senior Director here at Lux Research, and I'm moderating today's session. Presenting today is my colleague Ari van Berkel, Chief Product Officer here at Lux Research. Now, throughout the webinar, you're able to type any questions you have in the questions box on your screen, and time permitting, we'll answer all those questions that we can. If your question doesn't get answered, please don't hesitate to email it to questions@luxresearchinc.com and we'll respond. If at any point you experience technical difficulties, such as a frozen screen, simply refresh your browser and check that your internet connection is strong. Now with that, I want to jump into the discussion, so I'll pass it on to Ari.
All right, thank you, Josh, and welcome everyone. Thanks for joining our webinar here. We're going to talk about why innovation fails. Just to be clear, not because we would want your innovation to fail, but we would want you to avoid doing that. And then it really helps if you know why it's happening. And our thesis today is that you need to pay more attention to risk management, and we'll tell you why and how. We'll start with what is regarded as a very successful innovation. One of the innovations that the Shell Research Organization is probably most proud of is their development of gas to liquids technology, or as Shell puts it, their Shell middle distillate synthesis SMDS process, which is a very long duration innovation which started in the 1970s and culminated in a full-scale factory in 2003. In fact, they're so proud of it that they published a book in 2014, and I was fortunate enough to be gifted one, at the occasion of 100 years Shell research. And that book was totally dedicated to the history of their gas to liquids developments. I used a picture from the book here. You can see it. This is the pilot plant they built in Amsterdam. Now, this had a admittedly somewhat fringe business case. You could debate the business case of this particular development, but there was a clear business case, and it was about natural gas being stranded in places where people don't use a lot of natural gas, and it being very hard to move that natural gas to other places. And so what can you do? Well, you can turn it into LNG, but you can also turn it into liquids, essentially create fuels out of natural gas in the place where the natural gas is abundant. And that's what Shell started to do in 1990. Well, before 1993 even, in the 1970s they started the development, but in 1993 they started the initial pilot plant in Bintulu in Malaysia. And then in 2004, around 2001, Qatar started to incentivize major oil and gas companies to start building gas to liquid projects in Qatar. And the way they incentivize it is they essentially gave the gas for free. So you pay nothing for the gas, but you have to pay a share of the profits of your operation to the Qatar government. Shell started to study a front-end engineering and design study in 2004 for their installation. Exxon did the same thing. So these are two major oil companies, presumably possessing roughly the same information, looking at the world at exactly the same time. And they were looking at exactly the same offer by the Qatari government. Shell pursued the option and proceeded to have a final investment decision on what became called the Pearl GTL project, and then was breaking ground in 2007 to build the installation, and it took 4 years to build it, and in 2011 it started production. In 2012 it was at full capacity. Exxon, on the other hand, had a term sheet signed about their project, which they called Palm GTL. Looked at it for 3 years, did all their homework, and then canceled the project. So that's not the things that we're going to talk about, because these companies were looking at the same thing. Presumably their business case was looking pretty similar, at least should be looking pretty similar. Yet one of the projects, quote unquote, failed, and the other one was a success in the sense that the unit was built and is producing, and it actually provided a strategic advantage to Shell later on when premium fuels and clean fuels became really important. For example, you can now buy GTL marine diesel for small boats, which wasn't a thing before the Pearl GTL project was completed, of course. So we're going to look at innovation risks as an important thing to look at, right? So you're walking the tightrope today of first looking at risks. And once we've seen that, we're going to look at how to manage risks. And then there's a surprise risk that nobody ever mentions that you should know about. If you don't take that particular risk into account, you're not really managing risks properly, and you're missing opportunities. And that's the last thing I want to talk to you about today, which is how you can turn risk into an opportunity. So our thesis that we started this webinar with is that innovation is driven by risk perception, not so much by business cases. That doesn't mean that you don't have to make a business case. You have to, but the business case is not the deciding factor after all. And I'll tell you why in a moment. Before that, I want to show you how risk management is getting an increasing amount of attention. So this is a literature search that we conducted at Lux Research, but it was actually also inspired by a similar search that the authors of a major review article published last year on risk management and innovation did. And we got the same results that they did. So we can be certain that we did the same search just a little later. So we have a prediction for 2026. And what you can see is that innovation management, which is the dark green higher bars, is getting increasing attention from 1998 until today. Clearly, there's a large increase in the number of publications about innovation management, reaching about 5,500, close to 6,000 right now. But then within that literature about innovation management, you can look at risk innovation management, and you can see that that went from roughly 35% for most of the time to nowadays nearly 60% is talking about risk management in innovation. So clearly risk management and the role of risk management in innovation has attracted a lot more attention recently. And how recently? Well, perhaps not coincidentally, since about 2021. Why is that not a coincidence, in my opinion? Because as of 2021, the context of innovation has become a lot more uncertain. So you can make a business case, but if everyone starts to question whether your market projection is correct, because there's a pandemic or there's sudden war in the Ukraine or there's sudden war in Iran or whatever, then how valuable is your business case still? And we all know this. I'm assuming we all know this, right? Business cases are very sensitive to assumptions. So here, this is from one of our reports on long duration energy storage. And you can see if you assume that you are going to have 120 cycles of charging and discharging for a battery a year, and the discharge will last 4 hours, you get very different results from when you assume you are going to have 365 cycles per year and a 6-hour discharge. So if I were pitching to invest in compressed air energy storage, which is the leftmost bar in both charts, right? Then if I were pitching the left business case, I would end up with a roughly 50 cents levelized cost of storage. Whereas in the right business case over here, I would end up with about slightly under 20 cents per kilowatt hour. Guess what I'm going to pitch, right? And then we get a big discussion about whether my assumptions are correct. And am I going in the current market, is it realistic to assume that I will have 365, so once a day, profitable cycles? Who knows? Who is to tell? This is where you get into risk management. So the business case is one thing, and you need to do it properly. But then the business case tends to have so many assumptions that the discussion then is about the risk implicit in those assumptions, and you need to manage that risk. So what are people worried about when you present your business case? Well, you could worry about betting on the wrong technology, or you could worry about maybe not having the right business model. Maybe your go-to-market strategy is wrong. Maybe you're not starting your battery storage business in the right country. Maybe there's another country where right now it would be easier to enter the market. Or maybe your timing is just off. Or you're not using your R&D capacity properly. Maybe because you're doing this project, you're missing a huge opportunity elsewhere, and it would have been better to put your R&D capacity into that other project. Or maybe you're just not part of the right ecosystem. There's another ecosystem that is way more advanced and that is doing many more interesting things. This is all outcome-based. So this is what people worry about, but this doesn't really help us discuss the risk. So if you really want to discuss the risk, you have to take another look at it, and you have to look at what could cause the risk. So, and then you look at what is creating the risk, and you can see, well, there could be changes in society. There could be uncertainty because the opinion in society might change, or there could be a reputational risk, which could be you risk your reputation by launching this product. It could also be launching this product is very difficult for you due to your reputation. So for example, if you are a company that doesn't have a very good reputation in terms of sustainability, whether that is deserved or not, that's beside the point. Let's say people are suspicious about your sustainability claims, then you will find that there's a high risk of launching a quote-unquote sustainable product. Because why would people believe that? So you have a reputational risk in that direction. Could also be the other way around, right? You have a spotless image on sustainability, but you release a product that is, at least in the public eye, very polluting, and there goes your image. As a financial risk, there's technology risk, there's environmental risks, and of course, there's legal and regulatory risks. And these risks, to make things more fun, are not independent. These are not things that you can talk about in isolation. You cannot say, let's just talk about the technology risk, because the technology risk is tied to your environmental risk, right? Your technology risk contains maybe trade-offs. I won't go into it, and I probably shouldn't mention it, but I'm fairly sure everyone remembers how Volkswagen made a trade-off on their environmental risks, which included a technology choice that they made. And it didn't really work out that well, if you remember. Right? Societal risks and environmental risks are tied. I'm not going to go through all of these arrows. I'm sure you'll see all of the arrows and you'll understand most of them, right? But you can see how everything is tied together. So you're always trading off between risks. How do you manage this? This becomes a big discussion if you're not careful, and goes way beyond the remit of your product. And before you know it, you're having a philosophical discussion or a political discussion, even worse, with your colleagues instead of discussing the merits of your product and convincing them of why the project should be successful and should be tried. So let's go into that. Now, to do this, it makes sense to look at quantifiable and non-quantifiable risks. So you have to look, you can break down these risks, and this is an imperfect way of breaking it down, but it's good enough. And you can see roughly where you would find quantifiable risks and where you would find non-quantifiable risks. So financial risks tend to be very quantifiable. You can look at exact metrics like interest rates. And well, admittedly, capital expenditure is not an exact metric, but you can look at it nonetheless, and you know there's an uncertainty around it, right? You can look at raw material costs and how they fluctuate over time. Societal risks is not very quantifiable. You can look at maybe there's a backlash against my product or technology. Yeah, how do you quantify that? Maybe count the number of people that are opposed to it and see it increase or something. It's not that easy because it's usually kind of a wave, societal wave. You can look at unintended consequences, but of course, unintended consequences are hard to predict because they're not intended. You can look at societal movements that come and go. So you can see there's a lot of, and then if you look at legal and regulatory risks and environmental risks, part of those are very quantifiable, such as externalized costs, right? Liabilities. The cost of emissions are sometimes quantifiable, not always. But for example, there might be a CO2 pricing. You could look at sunk costs there as well. But there's also less quantifiable risks, like what happens to regulation and when does regulation kick in? What happens to access to the market? What happens to pollution that builds that is maybe not regulated, but that you still need to take into account? So with this framework, you have to look at the risks in view of the business case and the assumptions in the business case, but you also have to look at your broader business context. And there are ways to do that. So, for example, for quantifiable risks, a good way of doing that is to think of risk as it is commonly defined, for example, in quantitative risk assessments, which is probability times impact. And then there are various ways of managing that. So stage gating will help you reduce probability because you take it step by step and you gradually increase your exposure, the impact of the project failing, that's your exposure, by as you learn more about the development. So your learning, at least theoretically, keeps pace with how much you're exposed to failure. You can look at Monte Carlo simulations because that will really help you estimate real probability. It will help you estimate, put a number to probability rather than just a feeling. And it will really give you real numbers for probability times impact. You can also look at something like real options valuation. Real options valuation is hard to implement. I know, I've tried. And sometimes it works, sometimes it doesn't, but when you do it, it is a way to balance quantifiable risk against the potential return. So you're taking a risk, and the risk may be big, but maybe the reward is also big. And how do you balance those things? Real options valuation is an excellent tool to do that if you can master it. It's not easy to master, right? It's hard to master. For not quantifiable risks, the way to think about it is de-risking. And de-risking means options times agility. So you need to have options. Right? Do I have a way to change my plan if something happens? And how agile am I? Can I build agility? So not only do I have options, but also can I execute on those options? And to do that, to manage that, you can use scenarios, where scenarios will help you prepare for the right options. It will tell you what is your menu of options that you preferably should have. You can look at trends, and obviously at Lux we look a lot at consumer trends. I'll show you something about that later. So that will shape the messaging, and it will help you anticipate backlash. And finally, and I'll get back to this near the end of this webinar as well, you need to look at first principles. You need to look at vulnerabilities that are inherent to the technology you're developing. Every technology has vulnerabilities, and those vulnerabilities will surface. They will surface when your technology scales. We'll talk about that in a moment. And you can be prepared for it. It can even create an opportunity. So as an example of dealing with quantifiable risks, here's a successful innovation that Dow Chemical has when they introduced metallocene catalysts. So metallocene catalysts are single-site catalysts that replaced the incumbent catalyst at the time for synthesizing polyolefins. And they had a number of advantages. They allowed for a much better control, for example, of the molecular weight distribution. So you can make much more precise polyolefins. You can see the picture here. The picture is from Dow Chemical. It shows some examples of their elite products platform. And this actually allowed these kind of packaging, right? If you are old enough to remember, before the 1990s, we didn't have packaging that opened that easily. Now you have these packagings that you just rip open and you can close them again. And this sounds very trivial, but it's a pretty significant material development. And this was not without risk. So you had to switch from your existing catalyst platform to an entirely new catalyst platform with more expensive catalysts, which probably required you, but I wasn't sure, at least not clear at the beginning, to redesign some of your major assets. And those were big capital assets. They still are. So are you going to do that for a somewhat elusive advantage? The advantage is I can make better materials, but who cares about better materials? The current materials are good enough. So what's the market incentive to switch to the better materials? And nobody knew that we would want to package stroopwafels in a package like this, right? Dow made that leap of faith. And actually, it wasn't even their own technology. They licensed the technology from ExxonMobil. And then they went reasonably quickly. Within about 5 years, they launched their Insight technology, which is the name they gave to their production technology. And then in the 1990s, they already saw strong growth of their new materials. In 97, they created a joint venture between Dow and Exxon to license the technology. So now others can also produce it, but there's still a kickback to Dow. Or I don't know if that still exists, but there was a kickback for quite some time. They picked the risk they knew. So they knew the market very well. They knew their production process very well. So that's why they were in a position to license the technology and to make that bet on innovation. Another example of dealing with quantifiable risks is where Boeing postponed the use of composites. Boeing actually considered using composites for the fuselage of the 777. And that development started in 1988, but they decided against it. So they still used aluminum for it. Later on, in 2003, when they were developing the 787 Dreamliner, you can see the picture of here, they decided to go with composites finally. Why is that? Because they could model the uncertainties in using this new material. And back then, the uncertainties were very high. There's a large engineering uncertainty, there was a large manufacturing uncertainty. So looking at those uncertainties, they, I think rightfully, considered the risk too high 30 years ago and acceptable 20 years ago. So how do you deal with the non-quantifiable risks? I'll share you one example of PFAS. So PFAS was a wonder material, and you will remember that non-stick frying pans were a big hit. People loved non-stick frying pans. Until the whole sentiment, societal sentiment around PFAS changed. And then you can see, and this is a maturity curve about a culture, about a shared opinion within society. And you can see that the maturity curve of PFAS related to food, so essentially to non-stick pans, right? I don't want PFAS near my food. That's sentiment, that opinion is now shared in the US by 45% of the people, and it's growing. What's interesting is our prediction shows that there's waves coming after that. So it's pretty obvious to everyone in the non-stick frying pans business now that you will fail trying to sell those kind of pans if they include, if they're based on PFAS technology. But next up will be cooking and household goods. So you don't want PFAS in your household either. So, and that's slightly behind food, right? But then the next one is also coming already, which is cleaning products, where 32% of people now are suspicious of using cleaning products that involve PFAS. But that's coming and growing. So if you're in the cleaning products business, you now also need to really look at your product portfolio and be prepared. And then finally, at the very start of the maturity curve, there's a small group of people that have started to worry about sports equipment. So sports equipment, the kind of stuff you find at the gym, I'm using it, I'm feeling healthy. Well, to be clear, I'm not really using it, but let's say you're using it. I'm feeling really healthy. I enjoy using that. It is promoting my health, but it contains PFAS. So am I not in the same time affecting my immune system? And how do I deal with that? It's a small, and it's way too early to respond to that right now for you as a business, but you can see that risk coming. And this is how we deal with society. This is one of the ways we deal with societal risks. We can show you how certain ideas, certain opinions are growing. We call them cultures because it's a coherent group of people that share the same view on a certain topic. And you can see those cultures growing and coming. And once they enter, let's say, the later stages of early consensus, you need to be paying attention because they offer both opportunities and they offer issues for your products. There may be more coming around PFAS. And in fact, I'm pretty sure there is more coming. So there's a risk nobody mentions. And that is, you can talk a lot about the risk of your innovative project, but what's the alternative? One of the alternatives is another innovative project. So you definitely need to weigh different projects against each other and consider your risk appetite and consider the rewards as well. That's why I was talking previously about real options valuation. But there's another alternative, which is just don't innovate, do nothing. That is even riskier, is my thesis here. And in most cases, not always. And that's the risk that nobody mentions. So when you say this project is really risky, fair enough, and you should try to manage that. But at the same time, you should also weigh it against the risk of not doing the project. And that risk is also very real. When you stop investing in an industry, the industry starts to decline. So here I'm looking at data for the US as collected by the Federal Reserve, and I'm looking at data of how many people are employed in a certain industry. And you can see how these industries that are experiencing a reduction or even a halt in investment experience a reduction also in the number of people employed by the industry. And I'm looking here at how long it takes for the number of people employed by this industry to be only half the number it was at the peak of this industry. So going from the peak to only half the people are still employed. How long did it take? And sure, there could be some productivity increases, but that never results in 50% reduction in the workforce. For coal mining, the half-life of an industry is about 8 years. For apparel manufacturing in the US, it was about 11, textiles about 14. I did this previously for the Dutch textile industry back in the 1960s. It was about 10 years back then, so between 10 and 14 years, and for shipbuilding, it's about 10 years. Doing nothing results in a decline in your industry, and the half-life of your industry is about 10 years. As you can see, it varies by industry, and I'm sure there's noise in the signal. But overall, if you stop innovating, investing, renewing your industry, 10 years later, your industry or your company is only half its size. That's the risk of doing nothing. Western Union, for example, right? Alexander Graham Bell actually offered to sell his patent when it was hardly developed. It was just the patent, not any technology around it, in 1876. He wanted to sell it to Western Union, and Western Union refused. So they did nothing. They said, well, it's not very high quality. Our telegraph gets the exact message across, and here sometimes you have to ask people to repeat, there's noise, etc. We don't really know if everyone wants it. And by the way, it will go at the expense of our existing business. 25 years later, the Bell Telephone Company equaled Western Union's revenue. So clearly, doing nothing was pretty risky in this case. Finally, talking about turning risk into opportunity. And this is about structural risk. What do I mean by structural risk? There's a vulnerability in any technology. And we are pretty bad as humans, we're pretty bad at dealing with those vulnerabilities. And the reason is, again, look at risk is probability times impact. Our brains, when we think about things, deal very poorly with scaling and with nonlinearity. Scaling, let's say you find a slight disadvantage in your technology. Let's say you invented a car, a gasoline car, an auto engine, but you find that the engine doesn't really run properly. There's a knocking effect in your engine, and you have to deal with that. And then you find that if you add a little lead to the fuel, the knocking effect stops. Great. That introduces a vulnerability, because now your engine is spreading lead all over the place, quite literally, which cannot be good. But initially you think, well, you know, how many cars are there? So it's a little lead, but it's pretty similar to the background concentration. Who cares? We as humans, we don't deal very well with imagining what happens when that effect is multiplied by a factor 1 million or 10 million. We don't know, we have no imagination about that. We don't know what scaling looks like. We can do the math and we see the same numbers with a bunch of zeros behind them. It doesn't really ring that much of a bell. It doesn't really have a lot of impact on our thinking. And so what seems to be a manageable risk or a manageable vulnerability in your technology, once that technology starts to scale, eventually it becomes a problem and you hit a wall. You hit a societal wall where people say, we don't want this anymore. Wind turbines make noise. Okay, well, we can deal with a little noise. 1 wind turbine, 10 wind turbines, 100. When do we hit that issue? Wind turbines have an issue with birds. It's not a big issue right now. Contrary to what people are saying, it's a lot smaller issue than some other bird jeopardizing technologies out there. But what if it really scales? What happens? The other thing that we deal poorly with is nonlinearity. And this is about your innovation having an effect on the broader system. Changing the system. So your innovation, by implementing the innovation, changes the world. And so you have to look at your innovation and at the business case in view of the changed world, not in view of the current world. So it's non-linear. Your innovation is implemented, changes the world, and that changed world has an effect on your innovation again. That is also something that really is difficult for human brains. And you can benefit from the fact that we're not very good at thinking. So how do you do that? Well, here's a good example. There's a couple of bad examples as well. But a good example is DuPont and later Chemours. DuPont actually invented and introduced chlorofluorocarbons, right, CFCs, and those were the first refrigerants. And they were used in fridges, right? That was the first application. Now, they had a vulnerability, and the vulnerability was that they were dangerous to the ozone layer. And that was recognized pretty early on. We knew that that could happen. It was predicted already quite early when these products were released, but at the time it wasn't really a big issue. Until, of course, scientists started raising the alarm about holes in the ozone layer and how that could be very dangerous. Now, DuPont knew about the vulnerability and already started preemptively developing the next generation, which was hydrofluorocarbons. And not only did that, and so this is the scaling effect. In this case, they did a good job of imagining scaling, and they said, okay, this is a great product, but it will hit a wall, and we need to have the successor ready, and they did. It also is a good example of nonlinearity, because by releasing those new products, they immediately had an advantage over all of the competition, who by now was also producing CFCs. Because this enabled regulation. And this is an important thing to notice. When a technology creates an issue, there's an urge to regulate, but regulation doesn't always happen. If you look at leaded fuels, regulation, the leaded fuel and pollution by cars was an issue long before regulation emerged. Why didn't regulation happen? Because there was no option to regulate. And by now, cars were too big to regulate. So you couldn't really tell people, hey, we're taking your cars away. There was no option. And there was no technology that would allow the regulator to say, you have to be less polluting, you have to reduce your emissions, until the catalytic converter was innovated. I'm not going to say invented, we knew about catalysts long before that, but somebody came up with the catalytic converter and said, hey, we can put this in cars. And that triggered the whole regulation around removing lead from gasoline and insisting that pollution levels from cars would be driven down. And that is still going on. Chemours, successor in this case of Dupont clearly also did the same thing, because HFCs have a very high greenhouse gas potential, and therefore they also became untenable in view of the climate discussion, and they were now replaced by HFOs, hydrofluoroolefins, because those have a much shorter lifetime in the atmosphere and are way less potent. A lot more to say about risks, but here's the 3 things I hope you will take away from this webinar. Business cases are important for innovation, but they can be tweaked. Risks cannot be tweaked. They are things that happen to your project. And if anything, your business case exposes the risks. It tells you which assumptions you made and how risky those assumptions are. And then you need to manage the perception of those risks, and you need to have a credible way of dealing with it. And that is what determines the success of your innovation. Obviously, it doesn't work the other way around. If your business case sucks, then just don't start the innovation, right? If you cannot come up with credible assumptions that make the business case work, then don't do it, clearly. You cannot risk manage your way out of a bad business case. If you have a good business case, you still need to manage the risks. The risk nobody mentions is sticking with the status quo, is doing nothing, not innovating. And while that's an easy way out, and of course, at least you don't create your own risks now, but also by not creating your own risks, you're also depriving yourselves of the ability to manage the risk. So if you stick to the status quo, you cannot manage it, you're a victim of it. If you innovate, at least you can manage it. And then finally, watch for key inherent vulnerabilities, because they will materialize. PFAS, we knew the vulnerabilities. We knew these substances are forever chemicals. And that's a clear vulnerability. It doesn't take a genius to figure out that at some point will trigger concerns, societal concerns about the buildup of these substances. So there are key inherent vulnerabilities, and they will materialize. You can bet on it. There's no way they're never gonna bite you. If you are able to anticipate, then they turn into possibilities. They turn into opportunities for you. That's all I had to say about risks and about innovation for today. Josh, I've been busy. I hope you've been watching the Q&A section. Do you have any
Absolutely.
questions?
I think we have time for 1 or 2 here. And again, for those of you who are listening, if you didn't get a chance to ask a question, you can type it into the question box. And again, if we don't get it to you, get to your question today, we'll touch base with you after the webinar and get it. But I think the one question that I see most here as I look through is, you mentioned quantifying a risk a lot throughout the webinar. And you mentioned, kind of in passing, Monte Carlo simulation and creating quantifiable predictions can be really important. The question that comes up is, how many companies actually use those methods, right? And are they easy to use? Are they successful today?
Yeah. So yes, they are successful, but not enough companies are using them. It takes a bit of discipline. It takes data gathering to do it. And when you do it early on, I was actually just talking a couple of days ago to VITO. VITO is the Flemish Institute of Technology Development. They mentioned they were doing these kind of Monte Carlo simulations at a TRL of 1 or 2 already. If you do that, you will find that the uncertainties are massive. So you get a lot of noise, essentially. You get an answer and it will say, this is your answer, and it could be 200% more or 200% less, who knows? Which seems pretty useless, but it isn't, because to be successful, you then start to play around with it. So one thing you can do using Monte Carlo simulations is you can say, what if I had an idea in terms of research to specifically reduce this uncertainty? I noticed that the uncertainty in capital expenditure is killing me here. What if I have ideas to really first reduce uncertainty in capital expenditure? Don't care about the rest. Don't care about efficiency and all that. I need to deal with that too. But let's focus on this one, because my Monte Carlo simulation shows me that this is now the one that's most sensitive.
Mm-hmm.
That really helps to direct the thinking about the R&D and to really prioritize among all of the ideas you could do with this technology. It prioritizes what you should do first. That is extremely powerful. And I would say probably, from what I'm seeing, maybe 20% of companies are doing that currently.
Mm-hmm.
It's getting more popular. More people are starting to get into it, but it definitely could be used much more often by companies.
Yeah. So a clear capability to add on to that risk management piece. And in your opinion, what you're saying is, hey, it doesn't matter if it's early stage, late stage, you're looking for either inconsistencies or directions that you can then dive into and say to yourself, well, what's driving that? And then build your risk management strategy around some of those as you begin to elucidate what's actually there. So yeah, I think that's a really interesting point. And obviously you had a lot more to dive into, everything from under modeling societal changes to thinking about the status quo. So again, for those listening in, if you have additional questions for Ari, please do pass them forward and we'll get to them as soon as we are able to. But for today, thanks, Ari. That concludes our webinar. The slide presentation and the recording will be sent to all the attendees via email afterwards. But as always as well, after leaving the webinar, we always prompt you to complete a survey on today's presentation. We want to hear your feedback. We want to understand the types of webinars you want, because that really helps us improve things in the future. So please take a moment, fill that out on your way out. And again, thanks for joining us and have a great day.
All right, thank you.